So we're going to continue looking at factors that we have to consider when actually looking at more complex models in multiple regression. And some of these terms will also spill over to some of the other statistical techniques that we've talked about or are going to talk about. Now again, I want to really just remind you that what we're talking about in all of these slides over the last couple of weeks is complex multi-regressional models. So we're looking at multiple regression. We're looking at generally hierarchical regression. In other words, we're controlling the blocks of what we're entering. And typically, unless theory strongly suggests otherwise, our first block is going to be the direct effect of all of our IVs. In other words, the IVs by themselves. If we have a reason to suspect that we might have nonlinear trends, we may check those next. We may also then continue forth and look at interactions. When we're looking at those interactions, and again, with multiple regression, we are creating interactional terms by multiplying two predictors together. And again, before we ever test to see if that interaction is significant, we have already entered those individual predictors, predictor A and predictor B, in a hierarchical block prior to that as unique predictors of our outcome. We're now asking, after we've already allowed predictor A and predictor B to account directly for changes or relationships with our DV, our actual outcome, is there more to be explained in how they interact with each other? Now, within that framework, there are two different things that could be going on when we find an interaction. The first one is a moderator. Moderator variables are a variable that affects the direction or strength of the relationship between a predictive variable and a dependent variable. In ANOVA terms, this is a classic interaction. In other words, what's happening here is that how one variable, one IV, predicts the DV varies depending on the level of another IV. So for example, it might be that predictor A has no relationship with our outcome when predictor B is low, but predictor A is strongly related to our outcome when predictor B is high. Now, moderation is a statistical concept. Moderation does not make a causal claim. It doesn't make any claim that there is some form of relationship between these variables. It is simply determining that there is a statistical interaction and that you need to look at both variables together to truly understand what's going on. Now, in ANOVA terms, when we find a significant interaction, a moderation, we usually will no longer even talk about the direct effects because the moderation often includes those direct effects in the terms of an ANOVA. Because again, an ANOVA is looking at a single big model at one time. When we find a moderating variable in a multiple regression, we have already removed the variable of the direct effect. So a lot of the times we're still interested in those direct effects, but we're also interested in how strong is that moderation. So just something to keep in mind that because multiple regression allows us to look forward in blocks through hierarchical regression, and that once we found a relationship, we can parse that variance aside and not look at it anymore as we look at other potential variants that might explain outcomes in our DV. That the way we treat an interaction in multiple regression is different than how we treat it in an ANOVA. In an ANOVA, all the variance is being included in one blocked model, if you will. There's not individual blocks. And that's why that if we find an interaction in an ANOVA, we tend to ignore the direct effects of the individual predictors at that point. So again, I know this can be a little bit overwhelming and confusing at times. The term moderating variables in interaction are the same in ANOVA and multiple regression, but because of how we're looking at the data and how we're parsing out the data and the relationships and the variance, we do have to look at them somewhat differently. Now we have an additional possibility when we find an interaction in multiple regression, and that is a mediation. Mediator variables are a given variable may be said to function as a mediator to the extent that it accounts for the relationship between the predictor and the dependent variable, whereas moderator variables specifically specify when certain effects will hold. Mediators speak to how or why such effects occur. So remember I said that with moderation, we're not making an assumption of causation. We're not necessarily making a theoretical assumption. We're simply saying that there is a relationship, and we're trying to define the relationship in the term of strength of relationships. With a mediation, what we're actually saying is that one of the independent variables is actually functioning through a second independent variable, and together they're what's affecting the outcome in the DV. So on the next slide, I'm going to give a couple of visual examples of this. But again, you may ask, and rightfully so, how do I know if I have a moderator or a mediator? This is usually going to be determined by your hypotheses and your theory. If you're simply looking for the interaction of how variables might statistically influence your DV for the purposes of pure prediction, probably you're looking at a moderation. If you're looking at a hypothesis that suggests that depression leads to anxiety and anxiety leads to poor outcome, then if you find that interaction, you're going to look for mediation, because your hypotheses and your past theory are actually predicting a causal relationship. Now, whether your methodology actually supports your use of the word cause is very different. But for mediation, we're at least statistically examining, is there an A to B to C relationship? So let's look at those graphic representations on the next slide. So in its simplest of forms, a moderation, for example, might be commute time and job satisfaction, but it's moderated by gender. So what that would mean, for example, is that if we simply looked at the relationship between commute time and job satisfaction, we would probably find a direct relationship. The more you commute, the less job satisfaction you have. We also might find a gender difference, that if you're one particular gender or another, again, looking at gender simply as a binary in this case, you might find that is also related to job satisfaction, and both findings have actually been found in past research. But you may actually find that a better explanation of the research is that commute time has little effect on job satisfaction for men, while it has a larger effect for women. That would be a moderation. That it actually depends if you're a male or a female, our moderator, Z, on how strong the relationship is between our commute time, X, and our outcome, job satisfaction. So commute time doesn't cause gender that then causes job satisfaction. And gender doesn't cause commute time that then results in causing job satisfaction. So the other thing to think about, if whether I have a moderator or a mediator, is it logical for one to cause the other, or one to influence the other? And if that doesn't make a lot of logical sense or theoretical sense, then we wouldn't look for mediation. We'd look for moderation. What's simply the relationship here? And just briefly, I can tell you what's generally found, and this is actually from industrial organizational research, is that men tend to have longer commute times and are willing to commute more than women. And also men, and this has been changing as gender roles change, but traditionally in the past, men have been more focused on their careers, and therefore they're also more willing to commute, which means that that's having less effect on their job satisfaction. Comparatively, women traditionally have in the past been less likely to accept large commute times, and when they do, they find that commute time is also impacting their other roles beyond work, which also influences their job satisfaction. So again, for moderation, what we're saying is that one independent variable's level, whether it is a dichotomous categorical variable or a continuous variable, matters in the relationship between another independent variable, again, could be categorical, could be continuous, on job satisfaction or on your outcome. Mediation is different. Mediation says there is a relationship between our first predictor, work flexibility, and job satisfaction. The more work flexibility you have, the higher your job satisfaction. It also suggests there's a direct relationship between your work-life balance, so how well you're balancing your life and your work. And again, it has a positive influence. The better you're doing that, the better your job satisfaction. However, we also can find a relationship between work flexibility and work-life balance, such that the more flexibility you have, the easier it is to have work-life balance, which then in turn means that you have higher job satisfaction. So it actually is fairly interesting to believe, and you can basically kind of think about this logically, Whether or not you have work-life balance probably doesn't cause your work flexibility. In other words, it's not the thing, it doesn't come first. You don't have work-life balance outside of a job, and then because it's so good, you get a job with flexible work. However, you may get a flexible working relationship with your job, which allows you to focus better on getting a better work-life balance. So again, we have a theoretical reason to believe that work flexibility results in work-life balance, which results in job satisfaction. So we have both logic and probably in the past theory to suggest that this isn't just a moderator, this is a mediation. And then what we're going to test is how strong of a mediation. It may be a partial mediation. It may be work flexibility is related to job satisfaction, no matter what. But some of its relationship to job satisfaction goes through work-life balance. And if you didn't measure work-life balance, you'd be missing some of that effect. We could also have a full mediation. What a full mediation means is that once we put the mediator into the model, the actual direct relationship between our first predictor and the outcome, in this case work flexibility and job satisfaction, actually disappears. They're no longer significant. So that is also the difference between a mediation, full mediation, and a suppressor variable. A suppressor variable looks very similar to a mediation. The problem with the suppressor variable is, one, it isn't logical. Two, it's usually not balanced by theory. And three, it isn't that the work flexibility is working through the suppressor to affect job satisfaction. What's actually happening is that because work flexibility is related to that second variable, the suppressor in this case, it causes the suppressor to become related. So let me walk through that a little bit differently. Let me actually, again, kind of like, I really want you to get the idea of what's the difference between mediation and suppression before we move on to the next slide, because some of the next slides are going to actually look a lot like a suppressor variable. If a suppressor variable is what's going on, the suppressor variable, when entered into the model, initially has no relationship to the outcome. So if work-life balance was a suppressor, when I ran the initial correlations, I would only find two arrows. I would find that work flexibility was related to work-life balance. I would find that work flexibility was related to job satisfaction. I would not find that work-life balance was related to job satisfaction. So that last angled arrow to the right would not be there. Then when I put all three in the model, suddenly that arrow appears. That is a suppressor variable. In this case, with mediation, those three arrows are there in the univariate correlations. Work flexibility is related to work-life balance is related to job satisfaction, and work flexibility is related to job satisfaction. I'm now asking the theoretical question, does work flexibility actually move through work-life family balance? Again, based on logic and theory, to affect job satisfaction. So let's continue looking at the difference between these, and this time we're going to look at it from Venn diagrams, and I'm really just trying to give you different ways to kind of conceptualize what's going on. And it's a little bit difficult across the board when we're talking about multiple regression, because most multiple regression models are actually complex three-dimensional models where we're trying to parcel out variance from multiple predictors, including different forms of those predictors. So that's why we spend a lot of time trying to kind of get a two-dimensional view of what's going on through charts like this, and on the next couple of slides through Venn diagrams. So again, looking at the difference between a moderator and a mediator, and a lot of the original research on this was done by Barron and Kinney, and we're going to come back to those names in a minute. But again, so if we had, for example, commitment, intimacy, and years of marriage. So commitment is our first predictor, intimacy is our second predictor, and years of marriage is our outcome. You can just look at this chart and realize that commitment is related to years of marriage. There is unique variance explained between commitment and years of marriage. There is also a fair amount of unique variance explained in years of marriage by intimacy. In other words, intimacy actually is explaining more of how long a couple might stay married than commitment is. But also notice that there is a section where commitment and intimacy are related to each other, and that section is also predicting years of marriage. So basically, we have unique prediction of commitment in pink, unique prediction of intimacy in purple, and there's still leftover variance that could be given to each other. Basically, we could partial that over to commitment, we could partial that over to intimacy, but it might be that intimacy is influencing commitment. As your intimacy goes up, commitment actually becomes a better predictor of years of marriage. While if your intimacy is going down, commitment may be a less impressive or less powerful predictor of marriage. That would be a moderation. We're not saying intimacy results in commitment. We're not saying commitment results in intimacy. We're just saying there's a statistical relationship, and some of the actual outcomes variance is being explained by the interaction between the two. And again, we could be just giving this variance to intimacy. We could just be giving it to commitment, but it may actually be explaining a moderation where they're actually influencing each other in some way. And in that case, that would indeed be a moderator. Now, what would happen in a multiple regression, if it wasn't a moderation, we would find that that green section, the actual interaction between commitment and intimacy, would not be significant. Basically, the model would say you can give this variance to either commitment or intimacy. They're not interacting with each other. They just happen to be a little bit related, and they both predict years of marriage. But if we found that the interaction between commitment and intimacy, again, that interaction term that we created in multiple regression and added into a later block in the hierarchical model, was significant, it said it's not just shared variance. It actually is influenced variance. Commitment is influencing intimacy, or intimacy is influencing commitment. Now again, which one is the moderator? Honestly, that's up to you to decide. You can look at it either way. Again, sometimes there might be some indications due to commitment, or not commitment, there might be some indications due to past theory. A lot of times, if one of them is categorical, especially if a dichotomous two-level, that's usually what you want to kind of declare your moderator, because at that point it's a lot easier to look at the relationship. So, for example, if you had measured intimacy as a high or low dichotomous categorical variable, it'd be fairly easy to define this moderation, this interaction. What is the relationship between commitment and years of marriage when intimacy is at high? And what is the relationship between commitment and years of marriage when it's low? If both of these variables were continuous, we would go back to last week's lecture, where we'd actually have to choose high, medium, and low, based usually the mean and standard deviations of one of these variables to look at that relationship. If we're looking at mediation, however, this is what we're looking at. And again, I want to remind you that this does look a lot like we talked about when we talked about suppressor variables. But what's happening here is that there's relationships between these three variables in our bivariate correlation matrices. In other words, x1 is related to y, x2 is related to y, and x1 and x2 are related. And when we put them in the model, this would be an example of full mediation. The relationship, the arrow between x1 and y, would disappear when all three are allowed to be in an interaction. That would be an indication of very likely a mediation. x1 actually causes x2, which causes y. And this would be an example of a partial mediation. So again, x1 is related to y, x1 is related to x2, and x2 is related to y as well. However, there's also some mediation there. The interaction would be significant. And in this case, what would be happening is x1 does have a direct predictive relationship with y, but it also influences x2, which then influences y. So our mediational model, once we think we have a mediation, in other words, we found an interaction in a multiple regression, and we have theoretical or have hypothesized reasons or logical reasons to believe it's not a moderation, it's actually a mediation. We're going to have to go through a series of simple steps to determine, is it a mediation? And if it is it a partial mediation or a full mediation? And we're kind of focused on that direct effect. Is the adding of the mediation in the interaction removing the direct effect? So we're going to talk about mediation in a little more detail. We're going to talk about the methods for testing mediation, and we're going to spend a fair amount of time on normal theory method, because normal theory method allows us to test for a mediational model without adding any additional statistical techniques. It's using what we've already been using. We're using correlation, we're using SPSS. We're also going to talk about bootstrap distribution method, which has often been used more recently, but it does require you to know what program you're using and also to determine what macros. In other words, you're going to have to program SPSS to do this, or some other statistical program. And finally, we're going to touch off and then leave on partial mediation. By the way, I keep referring to Barron and Kinney and their landmark article in 1986. They are the ones that came up with what's often referred to as normal theory method, and here they are. A little bit of weird trivia. I actually was in a workshop once with Kinney, who is the person pictured to the right. We were actually paired together in a role-playing exercise where he was a fry cook in McDonald's and I was his manager. And I had to manage him as he was pretending to be incompetent at basically cooking fries. He's actually a fairly funny guy and fully mimed out burning himself and immediately demanding for workers' compensation during the role play that we did. This was on stage in front of 200 people. So that's my weird connection to one of these authors. Anyway, let's get into it a little more. So mediation occurs when a variable accounts for the effect. It accounts for the effect of the predictor on an outcome. The mediator is the reason why the predictor affects the outcome. The IV causes the mediator, which was an IV until we're trying to look for mediation, and the mediator, that second IV, now causes the DV. So for example, we might have a direct effect. Being bullied leads to social avoidance. But we also might have an indirect effect. Being bullied leads to fear of peers. Fear of peers leads to social avoidance. So being bullied is our first IV. Fear of peers is our second IV. And then the fear of peers leading to social avoidance would be our proposed mediation. So again, we would start with, is there a direct effect? Is bullying correlated with social avoidance? Is there an indirect effect? Is bullying related to fear of peers, and is fear of peers related to social avoidance? And then we want to ask what happens when we add the interaction into the mediation. In other words, we find an interaction, what's going on? Is the total effect of X on Y is C, and then C prime is what's left once we add A and B into the model. So the total effect on bullying on avoidance is the same as the product of the effect of bullying on fear and fear on avoidance, as well as the direct effect on avoidance. So what we're really looking for here when we're talking about looking for mediation is we first want to see a direct effect, C. We want to see a relationship between our independent variable and our proposed mediator, A. We want to see a relationship between our mediator and our outcome, B. And when we put all three in the model, we expect there to be a significant reduction in C. That's C prime. In other words, when we put in the mediator, we should see the relationship between bullying and avoidance directly either disappear, full mediation, or be significantly less, partial mediation. So like I said, there's a couple of ways we can test this. Normal theory method is Barron and Kinney, 1986. It uses a 4-step procedure that uses a series of regression analyses. So we're simply using the same tools we would otherwise. Shroud and Bolger in 2002 basically suggested that we should use a bootstrapping sampling path analysis using coefficients and a distribution of point estimates in indirect effects. So this actually uses confidence intervals instead of p-values. In other words, we're not actually creating a test statistic that we compare to a p-value chart. We're creating a series of bootstrap samples. What a bootstrap sample is if I have a sample of 200 participants, I'm going to draw a sample of 100 and I'm going to run an analysis. I'm going to run another sample of 100. I'm going to run analysis. I'm going to do this over and over and over again in a computer program. So what I'm basically doing is I'm creating a sample of my population that I'm going to compare my true sample to from my actual sample. So instead of comparing a sample of 200 to a hypothetical p-value chart based on an estimate of the population, I'm estimating the population from my sample itself by doing an iterative series of smaller samples out of the sample I have. In other words, if I truly have a significant effect, I should find it no matter which random group of people in a smaller group I draw from my big N. So my big N is the 200 people in my study. I pull out 30 of them, a small N of 30. Is it a significant relationship? I draw out a different sample of 30. Is it a significant relationship? I do that over and over and over again to get a confidence interval. And guess what? The confidence interval I'm usually looking for is, do I find the effect 95% of the time or higher? So it's still a p-value of 5. It's not, but we're not actually using a p-value as we traditionally think about it. We can also use even more advanced techniques and more advanced programs to be looking at these methods. The biggest advantage of bootstrap distribution method, and we'll talk about this a little bit on the last actual set of slides that we're going to go over, is that it is a little bit more accurate, and there is a problem with normal theory method, and we'll talk about that problem as well. It doesn't occur a lot, but it can occur, and that's one of the reasons that as computers have gotten better, computer programs have gotten better, and it's been easier and easier to add basically a syntax program to an existing stats program, we're often finding that those macros, and that's just a term meaning a series of code that we're going to insert into a statistical analysis, are being used more and more for this technique. But I think it's a lot easier to conceptualize what's going on with mediation with normal theory. So we're going to cover both. So here's the example we're going to work from. Jared is studying the effects of subliminal advertising on men's shopping behavior. His predictor is subliminal messages, and he actually knows these are happening first because he's introducing them. The operation, messages are embedded in music suggesting that men purchase fishing and camping equipment at Bass Pro Shop. The levels of the subliminal message music is basically whether or not they're getting Hank Williams Jr. hits with no subliminal messages or subliminal messages hidden within. The DV is the number of items purchased, and the mediator is whether or not they were paying attention to the music, operationalized by time amount spent in music. And the idea here is the subliminal message comes first, but the type of music with the subliminal message then influences how much time they spend listening to the music, which the more they listen to it, the more likely it increases their number of items purchased. We're going to use this example in the next set of slides to go through testing and mediation.